Welcome to Getting to Know Google SecOps. I'm John Stoner, and today we're going to introduce statistical functions for standard deviation and variance that you can use as you build searches and rules in Google SecOps. Let's start with variance. You may know this by another name, which is mean square difference, and that name actually provides a few clues how we arrive at this value. Let's take the numbers on the right side of the screen and calculate the variance. First, we take the values in the dataset and calculate the mean, which is 6.6. Our next step is to calculate each value's difference from the mean and square that difference, which also helps us get rid of the negative numbers. We can add these squared differences up to get the sum of the squares, which is 7.2, and to get the variance, we divide that value by the number of values in our dataset, 5. Based on this, our variance is 1.44. The good news is that we don't have to do all of that math ourselves. The function window.variance does it all for us. We just need to provide the field or variable that contains that numeric value. This function assumes that the data in the rule or search is being aggregated, which means that there's a match section, and this function will be used in the outcomes section. Once we understand how the variance is arrived at, the standard deviation is a snap, because the standard deviation is the square root of the variance. In our example, if the variance is 1.44, our standard deviation is 1.2. Measures like variance and standard deviation can be helpful when looking for outliers because we often assume that data sets have a normal shape to them and that the bulk of the data is very similar in its characteristics. But there are outliers on either side of that normal distribution. These outliers would have greater variance and a higher standard deviation from the mean. Similar to variance, we don't need to do the math to get a standard deviation calculation. We just need to use the syntax window.stddev, standard deviation, followed by the numeric field or variable. This function also assumes that the data in the rule or search is being aggregated, which means that there's a match section, and this function will be used in the outcome section. Let's use these functions in a search and then in a rule. Our search will focus on Zeek HTTP network events that are coming to a specific server in my network where the sent bytes are greater than 0. We can aggregate the results by the combination of the principal and target IP addresses. The outcome section will provide us with a method to count the total number of events, the average, the standard deviation, and the variance of the bytes sent. While our search is reasonably specific, that is focusing on a specific protocol and a specific product, my lab environment does not have very predictable traffic, so my variance and standard deviation look a bit wilder than a more tuned set of network connections. But hopefully this output gives you an idea of the kinds of things we can do with these statistical functions. Being able to search a time frame and gather standard deviation and variance and then refine it iteratively during a hunt can be useful as we hypothesize what might be driving our results. In our results, we can see our IP address pairs with an event count and the other measures. While it looks like some of our network connections are within a normal range, there are clearly some outliers. These functions can also be used in rules. The events section contains our criteria, while the match section contains our aggregation or grouping, with the addition of a 1-hour time window. The outcomes section contains the event count, average, standard deviation, and variance. Finally, in our condition section, we have established a threshold for the number of events and the variance and standard deviation. Because the variance and standard deviation are mathematically linked together, remember the square root of the variance is the standard deviation. Having both is a bit redundant, but hopefully this drives the point home. When we test the rule, we can see a detection with a very high standard deviation and variance. The functions window standard deviation and window variance provide additional statistical measures that can be applied to data sets in searches and rules. The syntax doesn't get much simpler. We just need a numeric value from an aggregated data set to calculate the standard deviation and variance. Remember that standard deviation is derived from variance, so you can use one or the other or both, whatever you'd like. If you want to learn more about Google SecOps, check out my blog series called New to Google SecOps for more handy tips. We have a number of community YARA-L detections at our GitHub site and are continually adding more. And don't forget to engage the security community at secopscommunity.com.